Are blue light glasses a scam? Well, to me, it seems that blue light glasses would only help if they remove some optical power from the light coming from your screen and go into your eyes. Otherwise, I'm not sure how they would really do anything. So, to investigate that, I would either need to buy a spectrometer for a few $1,000s or make my own. So, thankfully, there's a company called Theramino that has a lot of open source projects. And I'll link this in the description here, but they basically show you how you can make your own spectrometer for about $30 or less, depending on your how far you want to go. So in my case, I had a box that was a Cheerios box, and some cheap diffraction gratings from Amazon, and the cheapest webcam on Amazon. And I'll explain how that all kind of works together in a sec. But Theramino also releases software that crunches some numbers for you to give you the whole optical spectrum. So basically, the theory here is you shine light into your box. The light hits a diffraction grating, which is this thing here, and I'll explain what that is in a sec. And if the light is coming in like this here, where my mouse cursor is, then the diffraction grating has some property that splits out light, fans out its spectral components. So if this is white light here, you'd get red, orange, yellow, green, blue, purple, all that stuff fanning out. So the angle of diffraction is dependent on the frequency of the light. So quick intro to diffraction. So pretend here we have just red light of a single frequency. Now, if we have a hole in a wall, then that light will start splitting out like so. Very unintuitive property, I have to say. And the blue lines here are supposed to represent intensity of your light. So if here's your red wave coming in, maybe these blue lines are maximum indicators here. So that's really what our wave is. And then it'll spread out this way, whatever. Now, if you have a bunch of holes, like that diffraction grating is just a bunch of slits in a piece of plastic or something, then you see the wavefronts here kind of combine, and where you have two of these maxima, you'll have constructive interference, and where you have two minima, or a maximum and a minima, you'll have destructive interference, and you'll get some cool patterns. You'll actually see a pattern like this. And really, you don't need multiple holes to see this cool pattern here. Because if you have one hole, you can say that really one hole could have a ton of different point sources, and there's a bunch of math I'll link in the description. Anyway, the end goal is we want to have the light shining in on the diffraction grating like so. If this is the center of the light incident wave, let's say it's white light in this case, then red might have a spacing like this. Maybe blue will have a spacing that's a little bit wider or narrower or something. And if we go back to that Theramino spectrometer thing here, yeah, you'll see the diffraction grating kind of splits the light like this. So I'll show my build following the Theramino guide. Here, they recommend stripping off the case of your webcam. I didn't, just for simplicity, for a quick try here. So here I just hot glued a diffraction grating to the front of the webcam. Glued it in a Cheerios box. There it is, the other side, and I wrapped it in here's the front of it with adjustable slit size. And to make sure it is all dark, I wrapped it in a couple sweatshirts and stuff here. Here's the software shown on a PC. And let's go to the results. So in the Cheerios box, here is my iPhone's flashlight, just as a control. And you see here, the iPhone flashlight's really actually a blue LED with some phosphor that emits some sort of yellowy green wavelengths. And this might not be perfectly calibrated, but it doesn't matter. I was just trying to see relative response from this. Right here, this little orange bar is a measure of intensity. I couldn't figure out a way to get the software to have the y-axis stay constant. It's always fluctuating based on the percentage of the screen it takes up, which is kind of annoying. So you can't really compare based on height. You have to just look at this bar and stuff like that. So here's the control. Here's me putting a blue light glass in front of the slit, in front of the box. So you can see the orange bar over here. It goes down a little bit. But so the whole spectrum shifts down. So it's kind of like having sunglasses on that don't have a dark tint. Just to compare that, I also put sunglasses in front of the slit, and you see how dramatically that decreases. And now here's a Listerine bottle, which, as you expect, shows only blues and greens, kind of. Now, here is me shining a second laptop screen into the slit. And here's that with the blue light glasses in front of it. So not much of a difference with the blue light glasses. A little bit of reduction, assuming this is calibrated in the blue wavelengths. Yeah, and I found the big box, like the Cheerios box, works better than, here's like a 10 centimeter long box that the webcam came in. Yeah, I couldn't really get, I'm not sure how accurate these spectra are. So that's why I went to the big Cheerios box instead. So in conclusion, it doesn't seem like blue light glasses do too much, but it does take away at least some optical power. In the future, I'd like to see what the actual optical power difference is. The Theramina software is pretty primitive and doesn't give you the perfect idea. But I would highly recommend making this yourself. It only took a couple hours, and it was pretty cool to see everything.